Dear participants, now we have the next session by the Dr. Sourabh Shastri. He gave the presentation on towards generative AI models. Sourabh Shastri, sir. Dr. Sourabh Shastri, sir.
Yes, sir. Yes, sir.
Can you permit me to introduce
Yes, sir. Sure.
to the
Fine.
participant?
Sure, sir. Sure.
So, dear participants, today resource person is Sourabh Shastri, and he is currently working as a senior assistant professor at the Department of Computer Science and IT, Katwa campus, University of Jammu. Additionally, he is holding the charge of head at Computer Science Department and coordinator at University Institute of Engineering and Technology, Katwa campus, University of Jammu. He is doctorate in computer science from University of Jammu and also qualified NET and SET examination. His research interests include knowledge discovery, machine learning, data mining, and deep learning. He has an overall teaching experience of more than 15 years. Dr. Shastri has published more than 40 research papers in SEIE Scopus and UGC referred journals and has 610 Google Scholar citations with H-index of 11 and I-10 index of 13. Also, he has authored 2 books and several chapters for edited books. He has participated in various conferences, seminars, FDPs, and workshops. Moreover, he has delivered several guest lectures and organized various conferences, seminars, webinars, workshops, FDPs, placement drives, industrial visits, extension outreach activities. He is also a member of professional bodies including IAENG and CSR. He has always been a source of inspiration and excellent mentor for students. Sir, it is our honor to have such a great researcher as a resource person in our FDP, sir. Now, it's our turn, sir. Please take the session.
Thank you. Thank you. Thank you so much, sir, for the warm welcome. Dear participants, I'm going to share my screen. Just give me a minute. So I hope my screen is visible.
Yes, sir.
Yes, sir.
Please run in slideshow mode, sir.
Yeah, yeah. It is in slide.
Yeah, it's good, sir. Absolutely
Thank
good.
you. Thank you. Okay. Okay, sir. So good evening, participants. I'm Dr. Sourabh Shastri, and thank you so much, sir, for the warm welcome in this 1 week national FDP. So participants, I'm going to discuss on the topic enhancing sustainable agriculture, machine learning applications in water quality and crop recommendation. So basically, we'll start with machine learning and also we'll discuss about the applications, particularly regarding the sustainable agriculture, where we see some case studies also on water quality and crop recommendation. So this is the list of contents. We'll start with sustainable agriculture overview, then its importance, machine learning, its type applications, then applications of ML in agriculture particularly, then the steps in the design of ML model, data pre-processing in machine learning, model building, and then at last the case studies 1 and 2 regarding water quality prediction and crop recommendation. So the problem is sustainable agriculture, and sustainable agriculture means the best practices, farming practices to meet the current food needs. And at the same time, we have not to compromise with the ability of future generations. So we have to focus on the agriculture, and at the same time, the population of our country, India, as well as the global population is increasing day by day. And at the same time, the agriculture land is reducing because people are constructing their homes as well as buildings on the agriculture land, and day by day the land is basically reducing. So what is the solution to meet the requirement, to meet the crop yield? So for that, we have to focus on the sustainable agriculture. And it is very important for the long-term food security, for the environment health, economic viability. And as I earlier said that the population is growing, and food demand is also growing. So we have to focus on the innovative agriculture solutions. So sustainable agriculture, it balances the food production with ecological preservation. And the key components here are the efficient use of water as well as the effective crop selection. So efficient water use means water, we know water is a critical and also the limited resource. And in this summer season, we have the places in India where we don't have the sufficient water to, to watering the farms, to watering the crops. Proper management ensures the crops that gets the necessary hydration. And even in our homes also, if we have plants in our home, so in this summer season, it's very difficult to hydrate all the plants when we have the supply of water is very less. So effective crop selection is to choose the right crops for the specific conditions that boost the productivity. And machine learning, it can analyze the data to recommend the suitable crops. There are various factors that has to be considered, including the soil quality as well as climate and water availability. Why sustainable agriculture is important? We have different reasons like environment benefits, so that reduces the soil erosion and degradation. It enhances the biodiversity, ecosystem services. It promotes the efficient water use and conservation. Economic benefits are there to increase the farm profitability and productivity. It reduces the dependency on costly inputs like fertilizers, pesticides, and it supports local economies through sustainable practices. We have social benefits also to support the fair labor practices and enhances farmer livelihood, to promote the community well-being and rural development, as well as it encourages sustainable consumption patterns. Now, machine learning, as we know that it is a subset of artificial intelligence and that focuses on the development of algorithms. And as a computer student, we know that what is an algorithm. And machine learning also focuses on the algorithms, but at the same time, it focuses on the data as well. So data is very important these days. Whether we talk about machine learning, artificial intelligence, or deep learning, what we require in our hand is the data. And after that, we have to focus on these algorithms, that which algorithms we have to perform for making the predictions or taking the decisions based on that data. And these days, data is exponentially increasing everywhere, whether it is the healthcare sector, it is the agriculture sector, it is the defense sector. In any sector, data, we store the data in the digital form. It is increasing day by day. And on the basis of that data, we have to apply the algorithms for getting the results so that we can, we can predict or we can take the future decisions on through that data. So in machine learning, there are basic concepts like training data. So training data is the data which is required to train the model, and that consists of input as well as output pairs. We have the feature space that consists of the possible features or attributes that describe our data. And in machine learning, we have to build a model. A model is the representation of patterns learned from data by the machine learning algorithm. And then we have to go with the prediction to make the estimates or having decisions about the unseen or future data based on that trained model. And at the end, we also have to evaluate our model on the unseen data using the uh, performance measures like accuracy, precision, recall, and other evaluation criteria. As we have different types of machine learning, including the supervised learning, which contains the label data, means the label is also mentioned in the original data. And we have to train the model on some particular chunk of data, and the rest of the data we place it for the testing purpose. Second type is the unsupervised learning, where the model is learned from unlabeled data, where we don't have the labels in the data. And the third type is the semi-supervised, where we have some labeled data along with unlabeled data. And then the last type is the reinforcement learning, like learning through trial and error by interacting with an environment to maximize the rewards. So these are the various types of machine learning, and depending upon the problem, whether the problem comes under supervised, unsupervised, semi-supervised, or reinforcement, we have to make the different models. So next is the various ways we have to work are the applications of machine learning, like we have the problems of classification where we assign the labels to the input data points. Then we have the regression problems where we predict the continuous values. Similarly, clustering or segmentation is there where we group or make the clusters of the similar data point. Dimensionality reduction is there where we reduce the number of features while preserving the relevant information. Sometimes in our data, we have a number of features, and to work on all those features is not possible. We have the limitations of the machine as well as the limitations of the algorithms and other things. So in that case, we have to focus on those features which are basically required to make the predictions or to take the decisions. Then we have the recommendation systems to recommend the items based on some user preferences and behavior, like we go with online shopping on Amazon or Flipkart. So sometimes it recommends us to, if you are purchasing this item, so this item is also useful for you. That are the recommendation systems. Similarly, we can go with the natural language processing, where we process and understand the human languages, and computer vision is there, where we analyze and interpret the visual data. So when we talk about the machine learning, use of machine learning in agriculture, so then there is a term called as precision agriculture, where the machine learning enables the farmers to optimize the inputs like water, the fertilizers, the pesticides, and we have to analyze the data that comes from sensors. We can use the sensors or drones or the satellite imagery. So algorithms, they can provide insights into the soil health, crop yield prediction, and pest detection, leading to more efficient farming practices. And for crop monitoring and disease detection, so again, the algorithms, machine learning algorithm works to analyze the images of the crops to detect whether they have diseases, pests, and nutrient deficiencies at an early stage. So this early detection, it helps the farmers to take the timely action to prevent the crop loss as well as to improve the crop yield. So crop yield prediction is also, we can go with crop yield prediction on weather patterns or the quality.
Dr. Shastri, you are not audible, sir. Dr. Shastri, you are muted, sir. Please unmute yourself, please.
Now it is fine.
Yes, sir. Yes, sir. Absolutely fine. Please proceed, sir.
Okay, sir. Okay, sir.
Please go to that previous
So this
slide,
is the
sir.
list of. Yes, ma'am.
No, previous. I think from that slide onwards,
This
your
one?
voice was muted.
Which
Yeah,
one, ma'am?
yeah,
This
yeah,
one?
yeah, 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 yeah,
Okay, okay,
yeah.
okay.
Yeah.
So here I am discussing the various applications of machine learning in agriculture. Like we have the precision agriculture, where the machine learning algorithms are useful for enabling the farmers to optimize the inputs like the water, the fertilizers, and pesticides by analyzing the data from sensors, drones, and satellite imagery. So we can use the machine learning algorithms for getting insights using soil health. We can work with crop yield prediction and pest detection, leading to more efficient farming practices. Same, we can work for crop monitoring and disease detection. Again, the use of algorithms, they analyze the different images of crops for the detection of diseases, whether which diseases are there for the plants, the various pests and nutrient deficiencies at an early stage. So early detection always helps the farmers and the persons who are dealing with the agriculture to take the timely action and to prevent the loss of crop. And definitely this will improve the crop yields as well. So crop yield prediction is also an application where we can analyze the historical data of weather patterns or soil quality and crop management practices. So again, the models can predict the crop yields for the better decision making and planning. Similarly, the application is resource management. Again, ML algorithms are used for managing the resources like water, energy more efficiently through these predictive analytics and smart irrigation systems. We can make the decision systems also by using these algorithms. We can work for personalized recommendation systems, and definitely these recommendation systems helps the farmers for making the informed decisions about the selection of crops as well as the process of planting, that in which season, which plants we have to plant in the agriculture field. So next is the steps which we require for the designing of machine learning model. So whenever we have to work on using machine learning, the first thing which we require is the data. So first step is the collection of data. Sometimes we go with the secondary data and sometimes we go with the primary data. Sometimes the organizations, the agriculture organizations or the government provides the data on the websites. So that data we can use as a secondary data, and sometimes we can go to the fields and take the photographs, take the pictures, take the images, and that data is the primary data. The first step is we have to collect the data, and after collecting the data, we have to go with the pre-processing of that data. So data may have some problems like the missing values. Sometimes they have the outliers and other things. So the pre-processing is required to have we have to perform it after the collection of data. Then in machine learning, we split the data into different sets, like we split it into the training set, validation set, as well as test set for training the model. And then we have to test it whether the model is working properly or not. So fourth is the model training, that is the training of the model. So we have different methods of splitting also. Sometimes we use the whole load method, sometimes we use k-fold cross validation to divide the data into different sets. And after the training of the model, the next step is to evaluate the model, whether the model is working properly, whether it has the high accuracy, high precision, high good results. And if the model is okay, then we will go with the predictions on the unseen data. So these steps we have to follow. And for data pre-processing, these are the things which we have to work before training the model. They are the imputation of missing values. If the data has some missing values, we have to impute those values. Then we have Data may contain some outliers. We have to handle the outliers. Label encoding is there, normalization, standardization is there, handling imbalance class problems, feature selection, and data splitting. So missing value means that is if the data has some missing values. So if the data has missing values, then we use the several techniques for the imputation of those missing values. Like sometimes if the row has more missing values, we just ignore that row. Sometimes we replace the missing values with the mean, median, or mode of that observed values in the variable. Constant value imputation is also there. We replace the missing values with some constant values like 0, 1, etc. Sometimes we use linear regression imputation to predict the missing values using linear regression. K nearest neighbor imputation is also, we can use it for the imputation of the missing value. So depending upon the data, we can use any of the type for the imputation of missing values. This is how we work in Python, like to replace the missing values with the mean, we use the method data.fill_na, data.mean in place is equal to true. So these are the various ways we impute the missing values in Python. And the choice of the method, it depends on the various factors like the nature of the data, the amount of missingness, and the specific requirements of the machine learning tasks. So second is the outlier removal. Outliers are those data points that deviate from the rest of the data set. So if, for example, if we have a field like age, and we know that age of a person is maximum 100 years. So if we have a value 560, so 560 is actually not the age. So it means that value is the outlier. So outlier can occur due to the various reasons like measurement errors or experimental errors or some other anomalies. So managing outliers is also a crucial step while doing the pre-processing. And for that, we have different methods like Z-scores, IQR, or visual inspection using techniques like box plots, scatter plots, and histograms. So normally we use IQR method. That is a robust statistical technique for identifying and potentially removing the outliers from a data set. And it is based on the distribution of data within the interquartile range. That is the range between the 25th percentile Q1 and the 75th percentile Q3. So outliers are typically defined as observations that fall below Q1 minus 1.5 into IQR or above Q3 plus 1.5 into IQR. So we have to find out the IQR, and the values that are less than this or more than this, they are considered as the outliers. Similarly, sometimes we need the label encoding also. If we have the categorical variables in the data set and we have to convert those variables in numerical format, in that case, we have to encode those labels. So how it works, the first is to identify what are the categorical variables in the data set. Then we have to assign the integer labels to them. We replace those categories with the labels. We use the encoded variables problem. So we have the one-hot encoding technique that converts the categorical variables into a numerical representation that can be used as input to machine learning models. For example, we have the categorical variables green, blue, and red. So in label encoding, we just encode it like 0, 1, and 2. But in one-hot encoding, we convert it like if we have three variables, so we convert like it like 1, 0, 0, then 0, 1, 0, and 0, 0, 0. So we have different methods of encoding the labels when we have categorical variables. Similarly, normalization is also required when we have to rescale the numerical features to a standard range. Like we have to convert the values in a particular range, like 0 to 1 or -1 to 1. So normalization ensures that all features have the same scale to prevent the features with larger magnitudes from dominating those with smaller magnitudes. For example, we have a variable. Again, let us suppose we have a variable age, and the value of age is definitely, if he or she is an employee, so it may be from 20 to 60 years. But at the same time, if we have a variable salary with that, salary may be 1 lakh, 2 lakh, 4 lakh, or 5 lakh. So one variable has the range from 20 to 60 and the other has the range 1 lakh to 5 lakh. So in that case, we can normalize that particular feature or variable in some particular range. So we normalize all the features in a particular range. So particularly for distance-based algorithms and optimization algorithms, we use this normalization, and for that we use min-max normalization, also called as min-max scaling. It is a data pre-processing technique for scaling the numerical features to some fixed range, typically between 0 to 1. So in min-max scaling works like to identify the features, that is determine which numerical features in your dataset need to be scaled. Then we have to compute the min and max values, like to calculate the minimum and maximum values for each feature. And then we'll go with the scaling formula. And for each feature, suppose X, we have to apply the formula to scale all the values in some particular range, like 0 to 1. And once the features are scaled, they can be used as input for machine learning models. We can also go with the standardization, which is also called as Z-score normalization. Again, a pre-processing technique to rescale the numerical features to have a mean of 0 and standard deviation of 1. So again, we have to identify the features, we have to compute the mean and standard deviation, and then apply the standardization formula for converting these values to a particular range. And once the features are standardized, they can be used as input for the machine learning models. Next is sometimes we have the problems which are not balanced. So not class imbalance means that is we have unequal distribution of classes within the data set. Sometimes we have suppose we have a two-class problem, binary class problem, and one class is the minority class that has significantly fewer instances than another class, which is called as the majority class. So in that case, we have to work for this problem also. It affects class imbalance effects, like it creates the bias in the model training. It is difficult in learning the patterns or to
So just now you're muted, sir. So Dr. Shastri just muted, sir. Please unmute yourself once.
it's happening because
Yes.
I'm just okay. So we have these techniques like oversampling, where we increase the number of instances in the minority class. And when we have the undersampling, in that case, we have to decrease the number of instances in the majority class. And sometimes we use some more technique also, which is synthetic minority oversampling technique, where we generate the synthetic samples for the minority class. So these are the different strategies for handling the class imbalance problems when one class is the minority class and the other class is the majority class. Data splitting is there. Data splitting is basically required to split the data into different sets. For example, we have suppose 100 rows in the data, and if 100 rows are there, we have to divide it for the training as well as for the testing purpose. So training set is the set which is required to train the model, because for training the model we require the data, and suppose we take 70% of the data for training the data set. Sometimes we also divide the data set into 3 sections: training, validation, and testing. So the validation set is used to tune the hyperparameters. Algorithms have different settings, and for that we use some data for the validation set to increase the model's performance and to prevent the overfitting by providing an independent data set for model evaluation. And third set is the test set, which is basically required finally for checking the model, checking the model on the unseen data, whether the model is working properly on the unseen data or not. So this is how we have to divide the data. So different techniques are there for splitting also, like we have hold out method, k-fold cross validation method, leave one out cross validation method, repeated random test train splits. Hold out method is the simplest method, where we divide the data set into 2 portions randomly, and one set is the training set, other set is the testing set. The training set is used for training the model, whereas the testing set is used for the evaluation of that model. So whole load method is a straightforward method and is suitable for the large data sets. So we sometimes we divide it into 70-30, sometimes 80-20. So that is simple method called as whole load method. Then second method is the k-fold cross validation method, which is a resampling technique used to assess the performance and generalization ability of a machine learning model. So how it works, it splits the data set into k subsets, or sometimes we call it as k folds, and then training and evaluating the model k times, means in each iteration one of those k folds, suppose the value of k is 10, so one of the k fold means one out of those 10 folds, one set is used for validation or test set, and the remaining k minus 1, suppose it is 9, so that folds are used for the training purpose. So this process ensures that each data point is used for the testing exactly once. So this is the modified version of the previous one. This is the third method, which is leave one out cross validation, where this is a special case of k-fold cross validation, where k is equal to the number of samples in the data set. Now it is not 3, 5, or 10. It means the number of samples is the value of k. And here each observation is used as the validation set exactly once, while the rest of the data is used for training. This is particularly useful when dealing with the small data sets or to maximize the use of available data for validation purpose. Next is the repeated random test train splits. It involves the random splitting the data set into training and testing sets multiple times and evaluating the model's performance each time. This method is particularly useful when dealing with small to medium-sized data sets or when k-fold cross-validation is computationally expensive. Next step is the model building. In model building, we have to use the algorithms of machine learning for the building of the models. We have different machine learning models. For example, in this case studies, we use the logistic regression, random forest, code vector machine, k nearest neighbor. But in addition to these algorithms, we have various algorithms or classifiers which we can use for the building of the models. And then we have the valuation metrics for the classification purpose. And for that, we require the confusion matrix, which is a tool that is required to describe the performance of a classification model or a set of test data for which the true values are known. So it has 4 building blocks: true positive, false negatives, and true negatives. So these are the various performance metrics like accuracy, precision, recall, specificity, F1 score, which we require for analyzing the trained model. So next is the case study one, which is called as water quality prediction. So dataset has been used here for building the model for the prediction of the water quality. The link of the data is given here. So it has different features. The dataset has different features that like aluminum, ammonia, arsenic, barium, cadmium, and so on. Number of features are there. And one feature is there whether the water that particular water is not safe or whether it is safe. So that is a binary class problem where we have different features.
Sir,
Yes,
sorry to disturb you. You have taken the data set from Kaggle, right? Will that make any difference towards the research? Like it's Kaggle is already curated data set. So will that impact our research?
Ma'am, that depends if you are, suppose if you have to apply the different algorithms and if you have to learn how this algorithm works, you can use this data set. This is a secondary data set provided by someone, but the right choice is if it's possible, if you collect your own data, that is the primary data, then it is good for the research purpose. Suppose one of my scholars is working on neurological disorders. So at present, he is working on this country data set, but at the same time, we are visiting the hospitals to collect the primary data set. But sometimes to collect the primary data set is little difficult. It has lot of formalities and other things. But to start
Not
with,
that it is difficult, sir, but if you see the look at the data set, no, in Kaggle, when I see the data set, there are thousands
ma'am,
of rows and columns. I mean,
your
thousands
voice
of
is
rows. But real time, I don't have. I have only hundreds.
ma'am, your voice is very low. Hello.
Okay. You can hear me now?
Yes, ma'am.
Can you hear me now? Can you hear
Yes,
me
yes,
now?
ma'am. Yes, yes,
Okay,
ma'am.
see, when I'm taking the data from Kaggle, I get thousands of data. Like the rows, number of rows, it's like 2000 rows. But when I go for real-time data set, I have only 500 rows or 350 rows. That will once again impact my ML model, right? When I'm going for splitting of training data and testing data. So at that point of time, I will have very less amount of data and maybe my model may also flatter, right?
Right. Right, ma'am, right. Yours, because during if you are getting some secondary data, it has lot many rows, but at the same time, if you are collecting it from some primary source, definitely it is very less in comparison to that data, and sometimes it reflects on the results as well. But that depends, because in that case, you are actually working on the primary data set, and to provide the results on the primary data set is always better than working on the secondary data set.
Okay, so so in case if I'm working on the primary data set, then I will conclude it saying by you can try it on a huge data set. That's how I
But
have
ma'am,
to
see
conclude it.
one thing, if you are working on some primary data, suppose you are working on secondary data set and you are getting an accuracy of 98 or 99% on the model. But when you are working on your primary data set, your model only gives you 95% of accuracy. But the thing is that the data is basically collected by you. And if we work more on that particular data, the performance may increase. When more people are working on the same data, they use different techniques, or they use the data different data pre-processing techniques. So definitely the performance of that particular model may increase after that. And sometimes we can also do like this. Suppose you collect some primary data from one source, again you go to some other source and get some more primary data. We can club that data and make the data huge for working on that particular model.
Okay, okay. Thank you, sir. Thank you, sir.
Right, ma'am. So if suppose the students of MSc or students of masters, or even the researchers, if they start working, so initially to work on the secondary data is good to understand the algorithms, to understand how to apply the machine learning algorithms. But definitely when you are doing the research, so we have to we have to work on the primary data. We have to focus how to collect the primary data. For example, I am giving the example of my scholar who is working on neurological disorders. So we are trying to go to the different laboratories as well as hospitals to collect the original data, but the problem is same: we are not getting the sufficient data. But if we will go to different places, different sites, so maybe we get suppose 5 samples from one place, 100 samples from other slave. At the end, we merge all those samples for the decision making. So in this case here, this is a water quality prediction. Where we have used the data set, and it is a binary classification where we are showing whether the water is safe to drink or not. Different algorithms can be applied. Like here we have used the logistic regression models. Two measures here we are showing, like accuracy of that model and precision of that model. This is the confusion matrix, which I have discussed earlier. And then we are showing here the ROC curve of that particular model. So on a single problem, suppose this is the water quality prediction and we are getting data from a secondary source, we can apply multiple algorithms. Like here, I'm showing logistic regression. Then we can go with sport vector machine. Again, we have different results. Random forest is there, as well as k nearest neighbors is there. We can use different algorithms and then compare the algorithms on the particular data set that which algorithm is working best out of these algorithms to improve the performance of that particular problem. So here we have divided the data set and then work on the testing data set to predict whether the quality of the water is safe to drink or not. Similarly, this is the second data set, which is again a secondary data set, that is the crop recommendation data set. We have different features like the nitrogen content in the soil, phosphorus, potassium, temperature, humidity, pH value of the soil, rainfall, and so on. This is a multi-class problem because it doesn't have two labels. It has 22 class labels, like in which season, which crop is suitable for which crop we choose for the particular field, for the particular soil. So it has different class labels, and here again we have used the different algorithms, the logistic regression. This is the ROC curve for the logistic regression. Then sport vector machine is there. Then random forest is there, and k nearest neighbor is there. So the problem was to recommend the crop, that is on which soil we have to recommend the crop. As earlier in the starting I discussed, that is we are the population is increasing and the land is actually agriculture land is decreasing. So for the sustainable agriculture, we must know that which crop is suitable for the particular soil. So if we know in advance that for this season or for this particular soil, this crop is good for the particular season, so that will definitely increase the crop yield for that agriculture soil. So these type of algorithms of machine learning, they are using not only in agriculture or for checking the quality of water, but at the same time we are using the machine learning algorithms in every field, whether it is uh, the healthcare, or it is the remote sensing, or it is the banking sector or insurance sector. Everywhere we are using the machine learning algorithms for recommending the things as well as for making the decisions. So these are the two case studies which I have shown here in the in this presentation. So this is all from my side.
Participants, if you wish to interact with the professor, you can unmute yourself and have an interaction, please.
Sir, good afternoon, sir.
Good afternoon, sir.
Hello,
Good afternoon, sir.
Saurabh sir, good afternoon.
Hanji, good afternoon, sir.
Hello, Saurabh sir, good
Hello.
afternoon.
हाँ, sir.
Hello.
Your voice.
Sir, may I?
Sir,
Okay.
Oh, sir, please proceed. Andi. Ramesh Kumar, you are audible, and please ask your question, sir.
Participants, anyone wants to interact with the professor, please unmute yourself and
Hello, Saurabh sir. Am
Yes,
I
sir.
audible? Sir,
Yes, sir.
good afternoon. Sir, I am working on agriculture data set. So I have collected
Okay.
the data from various sources, but while going for my open tag, the directors or the reviewers will ask about the validity or the authentication of the data.
Okay.
So how can I defend for that, sir?
You collected your data set by your own.
Yes, sir.
So in that case, sir, my suggestion is you can involve some agriculture experts.
Yes, sir. I have taken the help of Agriculture University and I have collected the data, sir.
So for
Can
the
I-
authenticity of the data, I think if you collaborate with, or you can talk to the agriculture universities, someone is from the agriculture universities, they are there to authenticate that data. Because if you are not from the agriculture field like us, we are the computer from computer
yes,
science
sir.
background,
Yes,
so
sir.
only they can authenticate it. For
And
example, if we are working on healthcare, in that case, we have to consult the doctors as well, whether the data is authenticated or not.
okay. So
Right. So
I can refer their names at the data set, sir, while presenting. I can
yes,
refer
yes,
that
yes.
this is the
You can
source or
refer their names as well.
okay.
You talk to them, and even sometimes, in our research papers, we
Hmm.
also add their names as authors,
Yes,
co-authors.
yes, sir. Yes, sir. Yes,
So
sir.
that authenticates the papers also, that we have an expert from the agriculture sector, like we have an expert from the healthcare sector. So
Okay.
these days, this is the time of collaborations, and the people from different backgrounds, they are working collaboratively. So
Hmm.
I think that is the best thing, to collaborate with the persons from agriculture sector or the agriculture universities, and that will definitely, that will help you for publishing the papers as well.
Okay, sir. Okay. Thank you.
Hello, good evening, sir.
Good evening.
Sir, data collection is a very important one. So, suppose we are going with the Kaggle, the data set is belongs to their own country. But can you give some example or some example site that the data which will be given from India?
Sir, we have in India, we have some authenticate government portals. For example, if we require the healthcare data, so NRHM is providing the healthcare data, which is the data of the government, and
Yes.
we can work on that data, because on Kaggle and other resources, different people upload their data set, but the
Yes.
proper resources, the government resources, they are uploading their data on the government sites, the government portals. You can use that data for applying these machine learning or other algorithms. And
Sir,
in that case, we don't require any authentication.
sir, it's openly available, right?
Yes, it is openly available, sir.
Okay, thank you, sir. Thank you, sir.
Good afternoon, sir.
Government is actually taking the initiatives these days to provide the data to the computer scientists, so that they work on that data, and they provide some decision making tools, and definitely those tools will help the government as well. The government is in this interest, so that's why they are providing the data set freely,
Okay, sir. Thank you.
available for the. Okay.
Good afternoon, sir.
Good afternoon.
I'm Dr. Meenal Shah from Kota. Sir, I wanted to ask, can we use AI in studying social science research? If I take secondary data from some government websites, and I take data from World Bank website or ILO website, can I merge that data with the help of AI?
See, ma'am, these days AI can be used anywhere, whether it is social science or any science. The AI can be used anywhere. So if you are from social studies, so AI and social studies can also be merged. In our university, Jammu University, we have the professors of social sciences, and number of times they approach the professors of computer science, that is they want to collaborate with us. They have their data, and they want to apply the artificial intelligence on that data. So it's not impossible or difficult these days to apply AI on social science. We have available research papers. You explore the research papers, you will definitely find research papers on that particular field.
Okay. Thank you, sir. Thank you.
Okay, ma'am.
Good afternoon, sir.
Good afternoon, ma'am.
Sir, I'm Amani from Andhra Pradesh.
Right, ma'am.
Sir, I'm doing research on crop recommendation only. Can you hear me,
Ma'am,
sir?
your voice is breaking.
Madam, can
Hello,
you
sir.
repeat your question?
Yeah, sir. Hello, sir.
Repeat your question.
Yes, yes, ma'am. Yes.
Sir, I'm also doing research on crop recommendation using machine learning only.
Okay.
Sir, I'm also collecting samples from different places, and I already got the data from the soil laboratory. But in that, they are given different ways. Means that data is very less data. How many records for the to apply any algorithm in the crop recommendation, sir?
Ma'am, how much
How
samples
many
you have?
records?
How much samples you have? How
Up
much
to now,
samples you have? Yes.
up to now 700.
So you can apply the machine learning on 700 samples as well. It will work.
Sir?
Ma'am,
It will
you
work.
can apply
Thanks, Mr.
machine learning on 700 samples. Just go with what is
Hello, sir.
yes, yes. Ma'am, you can go with apply the algorithms on that sample, 700 samples.
Okay, 700 is enough, sir.
Yes, enough
Or
for applying the
more
machine
data,
learning. But if it's possible for you to increase your data, you can. But if it is not possible, then you can go with 700 samples. Work on those 700 samples, and in future, if you will get more samples, just add those samples in that data, and then again go with the new models.
Okay. Sir, one more. What are the soil properties? Are there 12 properties? But in the case study, you have mentioned only 5 to 6 only. NPK, pH.
Ma'am, that actually the data set which I have used that has only these features, but soil has a number of features, and
Yeah.
it's not important to work on all those features. It's your choice, or you can use the reduction techniques as well. That is, which features are important for the model building. So
Feature selection in the farmer feature
yeah,
selection.
you can go with feature selection as well to select the particular features to work on that.
Okay, sir.
Hardly it doesn't matter to work on all the features. We have to work on the important features.
Yes, sir. Yes, sir.
Right, ma'am?
Yes, sir. Thank you, sir.
Welcome, ma'am.
Sir,
Sir,
one more
this is
doubt.
Professor Subbarao.
Yes, sir.
Dr. Subbarao, I did my PhD from IIT Kharagpur, sir. I'm working on humidity using artificial intelligence, and then, of course, I'm adding some of the IoTs also.
Right, sir.
So I'm collecting the data from Telangana Agricultural University.
Okay,
Based
sir.
on the data, can I produce the different what we call seeds and the possibility of getting the results?
Sir, I'm not getting your voice is breaking actually.
Okay, sir. I'm Dr. Subbarao, sir.
Sir, yes, sir.
Presently I'm working on artificial intelligence for finding the effect of humidity on the crops.
Okay, sir.
So at present I'm taking 2 seeds and the data I collected from the Telangana Agricultural University.
Right, sir.
Now, what my idea is, if I mix these 2 datas,
you have 2
is
data
it
sets.
these 2 data sets which are available for different seeds?
Okay.
Using AI, is it possible to get a common seed which is capable of sustaining both the humidities? I mean, theoretically, practically you can implement it later, but theoretically, is it possible?
You are saying that you have 2 different data sets of 2 seeds.
Yeah, 2 seeds which will work differently based on the same humidity conditions.
Okay, so you have worked on both the data sets separately.
Yes, sir. Yes.
And now you want to merge those both the data sets.
Yes. I want a common seed which can sustain both the humidity conditions.
Yeah, I think it's possible, sir.
Okay, sir. Thank you.
Hello, Sourabh, sir.
Yes, sir.
Sir, one more doubt. Sir, which is the best method to identify what are the parameters needed to predict a particular entity?
Sir, that depends. you are talking about feature selection methods.
Yes, sir. Is there any specific method, or we can use
No,
any of the
that,
ExaBoost?
that depends upon, that is maybe in my case I will get best features from one method, and in your case you will get best features from another method.
Okay.
So this is all experimental work, and you have to go with all of them, and then you have to find out which one is the best.
Oh, okay, sir. Okay. Because I have implemented two methods, but I want to know, is there any exact method that
No,
has to
there
be
is
followed?
exactly not a particular method that is you have to go with only this method.
Okay.
That
okay.
depends upon the depends upon you.
Okay, sir. So, okay, sir. So while projecting our presentation, we have to say that these are the things we have implemented because it gives a better result for the accuracy. That's it.
Yes.
Okay, sir. Thank you. Thank you very much.
Okay, sir. Welcome. So thank you so much for inviting me in this 1 week FTP.
Thank you, sir.
Thank you, Dr. Kiran.
So on
Dr.
behalf of Shri,
Dr. Shastri, please.
sir, please.
Dr. Shastri, it's really a privilege, sir, actually.
Thank
It's
you.
a lot of in-depth content was there in your presentation, actually. Starting with basics to the way in which you implemented, and there is an in-depth discussion and even content also. It is in-depth. Thank you very much, sir.
Thank you. At the end, when participants interacted, it means they listened the lecture. So
Yes.
it's also a privilege for me to be here. So thank you so much.
Prasad, sir, please.
Shastri sir, on behalf of Shri Vishnu Engineering College for Women and the Department of CNC, we are thank you for accepting our request and delivering an excellent informative session on enhancing sustainable agriculture using machine learning. So, sir, really it's useful to the researchers to have a different ideas to take up their research in this agriculture domain. Thank you very much, sir. In future also, we are look forward the future collaborations with you, sir.
Sure, sir. Sure.
Thank you very much, sir.
Okay, sir. Okay. Thank you so much.
Thank you, and have a nice day, sir. Dr. Shastri, we'll meet you again.
Okay, sure, sir. Sure, sir.
Thank you.
Okay, sir. Okay, sir.
Participants, today all the sessions are finished. So tomorrow at 1 p.m. sharp 1 p.m. you all should join. Before 1 p.m. that's a better. So have a nice day. Thank you.
Thank you.